Radius of circle. The radii of smaller semicircles are 2 and 1 centimeter respectively. Find the radius of the orange circle. And so brilliant. This is 2. This is 1. We need to find this radius. Radius of the large circle is 3. That much we know. 6. It's a big circle. Right? There could be a center. This is the center of this circle. This is the center of this circle. There will be a center to the big circle. It will get broken as 1 and 1. This circle goes without saying. It is inscribed in this region. It just touches this circle, this semicircle. It just touches this semicircle, just touches this semicircle. What are the funda we need to use? If two circles are touching each other internally, distance between their centers is r minus r. They are touching each other externally, distance between their centers is r plus r2. Sum of the radii, difference of the radii. Brilliant, because we are having circles touching each other externally here and internally here. Our aim here is to find radius of the orange circle, this circle bang in the middle. Right? Let's mark out some territory. Let's mark this as A, B, C. And so this will be 2. This is 1, 1. This is 3. So AB would be r plus 2. AC is r plus 1. BC is 3. Now we've incorporated this, but we have not yet used the idea that the big circle touches the orange circle internally. Let's see if we can use that also. Very often in these kind of questions, it's slightly tricky. You've got to say, what am I not using? I cannot solve this question without using that idea. So use that idea. How can we use that idea? Take the center of that circle, join it to A. Let's say this point is D or P. Then this will be 3 minus r. I'll call this O. This will be 3 minus r. Brilliant. So far so good. Now how do we do this? We need to figure this out. We need to find r. There is this big triangle ABC which get carved out as ABO and OAC. You have to somehow use the idea that this triangle and this triangle sit in the big triangle. And so we have only this. We don't have a nice isosceles triangle. We don't have a right angle triangle. We have to figure some way out. Right? But we're given 3 sides of a triangle. What can we do? Given 3 sides of a triangle, we can find the area. We can find this area. We can find the area of the large triangle. And then we can say large triangle area is this plus this. Or we can do one better than that. If BC were the base, then this will be the altitude. Some altitude here. Area of triangle AOC would be OC into the height, half into OC into height. Area of triangle ABO would be half into OB into height. This is 2 times this. This is 1. This is 2. This area is 2 times this area. That's it. We are through. After this, we can find the 2 areas. How do we find the 2 areas? I'm looking at this triangle, triangle ABO. The 3 sides are r plus 2 plus 3 minus r plus 1. Perimeter is 6. Semi-perimeter is 3. Area of this triangle, square root of 3 into 3 minus 1 into 3 minus r minus 2 into 3 minus 3 plus r. Likewise, this triangle, perimeter is 3 minus r plus r plus 1 plus 2. Again 6. Semi-perimeter is 3. Area is 3 semi-perimeter into 3 minus 2 into 3 minus 3 plus r, 3 minus of 3 minus r, 3 minus r minus 1. This is this area. This is this area. This number should be 2 times this number. And so 3 minus 1 is 2. So 2 times square root of 3 into 2 into 1 minus r into r equals square root of 3 into 1 into r into 2 minus r. 3 minus r minus 1, 2 minus r. Straight away we can say that this will get cancelled and then r will get cancelled. Obviously the better way would be to square both sides, 2 outside. So I'm going to simplify this. 4 into 2 into 1 minus r equals 2 minus r. 8 minus 8r equals 2 minus r. 8 minus 2 equals 8r minus r. 6 is 7r. R equals 6 by 7. Done. Radius of the orange circle is 6 by 7. Delightful question using the idea that this triangle's area into 2 is this triangle's area. Half into base into height, nothing more than that. And the idea of two circles touching each other internally, externally, all of that.